Alright folks, so I'll do a couple of demonstrations to show you how to get through the Velocity Math Skills sheet. So when you guys open it up, it's going to look something like this. All I'm going to do for the examples is I'm going to show you how to set up some of the problems. So these are the actual problems you're going to solve, but I'm not going to do the, I'm not going to plug in the exact numbers and give you the exact answers, but I'm going to show you how to use the information I gave you. In terms of slope in a mathematical way, slope is just the change in y over the change in x or the rise over the run. Now we're going to apply that in terms of physics because when we calculate velocity we're going to have distance divided by time. Therefore, if you had a distance and a time with distance on the top, time on the bottom, the distance is kind of like your change in y and the time is like your change in x. So if we were going to either plot that on a graph, vertical axis being distance, horizontal being time, collecting the data, maybe you just have two data points like distance and a time instead of x and y, we want to be able to find the slope between them. So in the first example they're asking you to literally just calculate slope. The equation for slope, as listed above, looking at the ordered pairs that they give you 1, 2 and 6, 3. 1 is to the left of 6 in terms of x from left to right, so this is your x1. Now looking at the ordered pairs that they give you 1, 2, 6, 3. The 1 falls before the 6 in terms of x, so from left to right, as if we were going to be recording slope, this ends up being your x1 and this ends up being your y1, and the 6, 3, this is your x2 and this is your y2. So if you simply plug those into the equation that you get, you should be able to figure out what the slope is. Now for problem number 2, they're basically doing the same thing except for they're giving you distances and times. So if you read what they give you 2 minutes at 0.4 kilometers, 5 minutes at 1.0 kilometers. So if we think of this in terms of distance and time, or x and y, really your first point is 2 minutes and 0.4 kilometers, and your second distance and time is 5 minutes and 1 kilometer. So if you're trying to figure out slope, it's the same. In terms of ordered pairs, it would look something more like this. You would have minutes at 0.4 kilometers, and I got 5 minutes at 1.0 kilometers. So think of this as your x1, y1, and think of this as your x2, y2. What you're really finding here then would be the velocity. It's not labeled directly as that because they haven't really brought it up, but if you did distance divided by time, in this situation change in y's over your change in x's, you have kilometers per minute. So everything you get here is going to be a kilometer per minute, which is a velocity, even though we normally measure it in meters per second. So number 3, that's all you. For problem number 4, you want to list, for all of these problems, you always want to list the distance, velocity, and the time. Those are the only 3 variables we're dealing with, and we're going to have one equation for each one. So if you want to think of always listing the v, the d, and the t, just know that they're going to give you 2 of the 3, and then you're going to have to solve for the other unknown. If we're trying to solve for distance, we know that velocity is distance divided by time, so that means we're going to be using the equation for distance, velocity multiplied by time. So you can set up what you got, you can see that hours will cancel with hours and we should get kilometers. And for problem number 6, this is talking about the longest stretch of railroad, straight stretch of railroad track. They say the track extends and they want you to figure out how many kilometers per hour the train is going. So we know that velocity is going to be d over t. So plug in the units that they give you, and then again just know that your result here is going to be in kilometers per hour. So whatever you get for this is going to be kilometers per hour. So I'll be looking for 2 things with your answers. One obviously is the numeric value that you get after you divide or multiply. Is that correct? And then also I'm supposed to see if you guys are getting the right units also. Okay? So that's it for the motion math skills examples. If you guys have questions, feel free to email me. All right. So I'll talk to you guys a little bit here about the average velocity of a rolling object. So in this lab or activity, you guys are basically going to be measuring various distances and times of an object rolling down a ramp or down an inclined plane of some sort. Now, I won't read directly through these instructions because I'll leave that for you guys, but basically you can pick any round object. You can pick something as small as a marble, or maybe something the size of a golf ball, or if you even want to do like a tennis ball or a soccer ball or a basketball, you can. But just know that you need to somehow measure the distance and also get a time of the object as it rolls. So if you're trying to keep this compact or something that's a little bit smaller, I recommend using a small object. So if I look at the data table, the data table kind of tells what data needs to be collected. So first thing here is the length of a ramp. So you guys can create a ramp, you can build a ramp, or you can use something that you got around the house. For example, maybe you can just find an old piece of wood that's got a groove in it. Maybe you got some sort of a plastic or a metal ramp at home that you can use. Maybe it's like some old toy like a slot car or whatever it may be. And then of course whatever object it is that you're going to roll. So the problem is asking how will the slope of the ramp affect the velocity? Well, the slope of the ramp has to do with the steepness of the ramp, so how high you lift one side of the ramp. So things to consider, your overall length of the ramp, and you guys will use your own measuring devices, but you're probably going to want it to be at least approximately that length. Now you could be using rulers or a tape measure or something a little bit different, but either way you still need to measure the total length of the ramp and the height of the ramp. So determine what that is going to be. If you guys are feeling adventurous and you want to take this to a much larger scale, you could do this outside. If you had a long hill or like your sidewalk or someplace outside and you wanted to roll an object, you could do that. The only thing that you have to consider is you still need to measure the total change in height. So if you use a small object such as a ramp, it's pretty easy to just lift up one end of the ramp and either set a ruler or a meter stick or something there to figure out the height. If you're actually outside and you're rolling something down a hill, we need to know how far it actually falls, and you may have to find multiple hills for multiple steepnesses. But if you wanted to make this as a larger scale, using plywood or something outside and build a ramp that you can adjust, that would be great. But my recommendation, keep it simple, keep it compact, keep it inside. Once you determine the ramp you're going to use, you can measure that length, because the length of the ramp will always stay the same. So if I'm going to be using this ramp and I want to determine where the start and finish is, I can pick, in essence, any distance that I want. If I want the length of the ramp to be 40 centimeters, I could just mark off maybe with a piece of tape or a pencil, set it at 40 centimeters, because the length that the object actually rolls will not change. The variable that you are changing is the height of the ramp. So the height of the ramp is going to be from one tail end, whichever end you're actually lifting. Then you're going to do 4 different heights, and for each height you're going to be measuring 4 different trials. And the trials are just rolling the object and timing the object. So you do it 4 times from each height and then change the height. People do get carried away trying to get to too extreme of a height. The problem if you get the height of the ramp really, really tall at an extreme angle, when you go to roll the marble, way too fast to actually time accurately. So my recommendation is to definitely keep the ramp as low as possible while the object still moves. So I could do one trial at 5 and 10 and 15 and 20. So your highest trial could maybe be at 20 centimeters. You don't have to change the increment by much. You could go up 1 or 2 centimeters at a time. That would be perfectly fine. Once you've done this, you can calculate your time average. Take all 4 trials, add them up, divide by 4. And once you've found the time average by dividing your numbers out, you can go and calculate average velocity. And remember, average velocity would be distance divided by time. Keep in mind your distance is the length of the ramp, not the height of the ramp. This is how far the object rolled. It's always going to roll that same distance. You're doing distance divided by average time to get your average velocity. Then if you flip over to the back side, you'll see that there's a graph. Now in the directions it says for you to make a height versus velocity graph. So how tall the ramp was versus how fast the object was going. So you can do height versus velocity or velocity versus height. That I leave up to you. But bottom line, there should be at least 4 data points. You could have one be at 0, 0, which would really give you 5 data points, but you have 4 average velocities and 4 height of ramps. So I think we know maybe as the height of the ramp changes how that's going to affect the velocity. So be sure to do that and incorporate a conclusion, and you guys should be good to go. If you have questions, please feel free to let me know, and I'll try to help you guys out. Thanks a lot.